Let us now look at the limit clause. So what I have here is a simple query. It goes to the characters table, it filters for the rows where the character is alive, and then it gets 3 columns out of this. So let's run this query, and you can see that this query returns 11 rows. Now let us say that I only wanted to see 5 of those rows, and this is where limit comes into place. Limit will look at the final results and then pick 5 rows out of those results, reducing the size of my output. And here you can see that we get 5 rows. Now, as we said in the lecture of ordering, by default, there is no guarantee of order in a SQL system. So when you are getting all your data with a query and then you run limit 5 on top of it, you have no way of knowing which of the rows will be selected to fit amongst those 5. You're basically saying that you're okay with getting any 5 of all of the rows from your result. Because of this, people often will use limit in combination with order by. For example, I could say order by level and then limit 5. And what I would get here is essentially the first 5 most inexperienced characters in my dataset. And let us say that you have a problem of finding the least experienced character in your data, the character with the lowest level. So, of course, you could say order by level and then limit 1, and you would get the character with the lowest level, right? And this works. However, it is not ideal. There is a problem with this solution. So can you figure out what the problem with this solution is? The problem will be obvious once I go back to limit 5 and I look here and I see that I actually have 2 characters which have the lowest level in my dataset. So in theory, I should be able to return both of them because they both have the lowest level. However, when I write limit 1, it simply cuts the rows in my output and it is unaware of that further information that is here in this second row. And in the further lectures, we will see how we can solve this better and get results which are more precise. And if we look at the logical order of operations, we can see that limit is the very last operation. And so all of the logic of our query is executed, all our data is computed, and then based on that final result, we sometimes decide to not output all of it, but to output a limited number of rows. So a common mistake for someone who is starting with SQL is thinking that they can use limit in order to have a cheaper query. For example, you could say, oh, this is a really large table. This table has 2 terabytes of data. It would cost a lot to scan the whole table. So I will say select star, but then I will put limit 20 because I only want to see the first 20 rows. And that means that I will only scan 20 rows and my query will be very cheap, right? No, that is actually wrong. That doesn't save you anything. And you can understand this if you look at the map because all of the logic is going to execute before you get to limit. So you're going to scan the whole table when you say select star and you're gonna apply all of the logic, and the limit is actually just changing the way your result is displayed. It's not actually changing the way your result is computed. If you did want to write your query so that it scans less rows, one thing you should do is focus on the where statement actually, because the where statement is the one that runs in the beginning right after getting the table, and it is able to actually eliminate rows, which usually saves you on computation and money and so on. However, I do need to say that there are systems where writing limit may actually turn into savings because different systems are optimized in different ways, and allow you to do different things with the commands, but as a rule, usually with SQL, limit is just changing the way your result is displayed and doesn't actually change anything in the logic of execution.